Hi folks, we're going to take a look at the solutions number 5 from the Unit 1 Lesson 8 sheet. So here we've got the derivatives of some functions, and we're going to try to determine them for the first time without using the limit definition. Okay, so we're going to do that by using our derivative properties that we found today. Okay, so let's start with this one here. We have a polynomial. So polynomials are made up of powers of x with coefficients and addition, subtraction. So perfect for the properties we found today. So if I want to find the derivative here, so this time I'll use the prime notation. Okay, now normally I wouldn't expect you to necessarily write as much of this, but I'll just show how those properties are being used. Okay, so first here we have a constant times a function, so the derivative of 3x cubed can be found by finding 3 times the derivative of x cubed. Okay, and then minus here, well, the derivative of x squared. So again, here we're using the constant multiple rule, we're using the subtraction rule, here we're using the addition rule and the constant multiple rule. Okay, and then here minus the derivative of the constant 12. Okay, so here we see one of the reasons why this Leibniz notation is useful is because when we're just working with the expression as opposed to the name of the function, it's much easier to use Leibniz notation. So here we've got 3 times, and here the derivative of x cubed is 3x squared. So the exponent becomes your coefficient, and the new exponent just goes down by 1. Okay, then minus derivative of x squared is just 2x, plus 4 times the derivative of x, that's just 1, and the derivative of a constant is just 0. Okay, and now we can simplify. So here 3 times 3x squared is just 9x squared minus 2x plus 4, and there's our function. Okay, now not surprisingly, I hope you notice that this cubic has become a quadratic. Okay, that shouldn't be surprising since all the powers we expect to go down by 1. Okay, perfect. Let's move on to the next one. Now here we have this root function, but in order to use our derivative properties, we're going to rewrite this as an exponent. So we're going to rewrite this as x to the 4 over 3. Okay, and so now we can find y prime, and we can use our power rule. So this exponent of 4 over 3 now becomes our coefficient. Okay, and our exponent just becomes 1 less. Okay, so the derivative of y is just 4/3 times x, and 4/3 minus 3/3 is just 1/3. Okay, and there's our answer. Now, this one here, got to do a little bit of work because, you know, you might sort of say, well, maybe we can just split this up as the quotient of the numerator and denominator. So just take the derivative numerator and divide it by the derivative of the denominator. But we haven't established that that's a rule yet. Okay, so until we do that, we should not assume that that's going to be correct. Okay, but what we can do is do a bit of algebra here. So what I can do is split this up into 2 fractions. I can split this up as x cubed over x squared minus root x, which again I'll write as an exponent, so I can make use of the algebra that I know. Okay, and so here this can just reduce to x, and minus in here 1/2 minus 2 is like 1 over 2 minus 4 over 2, so that's x to the negative 3 over 2. Okay, so now I can take the derivative very easily because I've split it up into a difference of 2 powers of x, each of which I can find the derivative of. Okay, so the first one, derivative of x is just 1 minus, okay, and now I'm going to take the derivative of the second one. So remember, the exponent, negative 3/2, becomes the coefficient, and then the new exponent is just going to be 1 less. So it's going to be negative 3 over 2 minus 1, so minus 2 over 2. So in the end, I have 1. This is going to become plus because I'm subtracting a negative. 3/2, okay, times x to the negative 5 over 2. Okay, and please keep in mind that we are going to be strict about our rule here about not having negative exponents in the numerator there. Okay, so here I'm going to rewrite this as 3 over 2 times x to the 5 over 2. Okay, and you can leave it like this. So just to recap, okay, when you're finding these derivatives, you are using these derivative rules that we found today. However, I don't necessarily expect you to write them out each single time. Okay, a couple of tricks to remember. When you have roots, rewrite in terms of exponents. And here, if you don't have a rule that can be immediately used, maybe there's some algebra you can do to get you to the point where you can use one of those rules. Okay, that's it for these.